Hello and welcome to Exercise 5 of our Environmental QGIS for Beginners course. In this section we'll be looking at how to use QGIS more efficiently, covering the topics listed in the description box below. To start, in your training data folder, locate the folder 01 Training Data, 00 Workspaces. Open Exercise 5 Gaia and save it to your working folder under 02 Training Outputs, 00 Workspaces as exercise5.qgs. Although we've edited the attributes of the weed points in a previous exercise, we now need to add a missing weed location to the Beaufort Inlet on our map. An example of when you'd use this function could be when you've returned from the field and noticed that a point collected in the field isn't actually represented in your layer, so you need to add it. To do this, in your table of contents, right-click on the Lakes layer and open its attribute table. Search for Beaufort Inlet and highlight the row. Just as a hint, you can sort the name field alphabetically, makes it easier to find what you're after. And once this is highlighted, close the attribute table. Now zoom to the highlighted inlet on your map using the Zoom to Selection tool in the top toolbar. Pan your map canvas up until you can see the end of Millers Point Road. In the table of contents, select the Weed Points layer and turn on editing by selecting the Toggle Editing button in the top toolbar. This editing toolbar allows you to add, delete and modify data. If you look at your weed points layer in the table of contents, you'll see that it's indicating that it's in editing mode via a little pencil alongside it. Go back to your editing toolbar and click the Add Features button. For a point layer, this symbol will be 3 little points. Clicking this tool will turn your cursor into a small target symbol in the map canvas. So in the canvas, click the very end of Millers Point Road near the inlet. The attribute form for that dataset will appear. Don't worry if you can't see the crosshairs at this point. Fill out the attributes for this feature as follows. For ID, we'll put 29. The common name is arum lily, and make sure you use the right capitals and lowercase letters here. The species name, and I hope I pronounced this correctly, is Xanthodetia aethiopica. For the collection date, put 2014 0303, and the amount is 1, and the recorder is s.smith, and leave the other values blank. And click OK. In the editing toolbar, click Save Edits. The new appropriately coloured weed location should now be visible in your map canvas. Remember that in a previous exercise we defined the symbology of this layer based on a field, so we don't need to specify it for each point. Click on Zoom Full in your top toolbar to pull back to your map canvas full extents, and click Deselect Features from all layers in the top toolbar to unselect the inlet. Although you have a new point, the eastings and northing fields are empty as these aren't automatically created. The coordinates are stored in the geometry of each data point, but not visible as field values. It may be important to populate these coordinates so that a table can be exported as a spreadsheet for a report or placed in a map. To update these accurately in your attribute table, you can add the values using an expression. Right-click the Weed Points layer and open the attribute table. Highlight the row of your newly created feature. Just as a note, you can use expressions to update all features or just the selected ones. The toggle editing mode should already be turned on. Now we're going to create an expression for your easting field. So the symbol that you want can be found in the function list geometry. That's this one here. Then click Update Selected and repeat this process but for northing and using the expression $y. Save your changes. The new coordinates should now be visible in your table. Deselect the features from all layers. And note that if you can't see your changes after running an expression, just try resorting the field to refresh it. On inspection of the weed points, we might also discover a data point that's in the wrong location and we need to move it. It's a common issue that data points are created at a more regional scale and they need to be adjusted so that they don't fall on, say, a road or a building. The weed point we're going to look at is ID 26, which currently sits on top of a road. So ensure that the weed point layer is still selected in the table of contents. Then use the Identify Features tool to locate the weed point with an ID of 26. And zoom in closer to its location. The weed points layer should still be in editing mode. If not, click on Toggle Editing. Click the Move Features tool, and then click on the weed location with ID 26 and drag it north slightly off the road. Click off the Toggle Editing button in the editing toolbar and click Save. Zoom back to the full extent of your map canvas. Note that this exercise is commonly done with aerial imagery as a backdrop, because it allows the GIS officer to use field notes, memory and visual cues to make these adjustments to the position of a feature. Can you think of a situation in your own work where this data cleanup might be important? Next, we need to create survey boundaries in QGIS from point data that's been collected by someone walking the ground in the field. A common workflow for the GIS officer is importing and exporting data for the purpose of supporting field data collection. Companies with field operations will often have handheld GPS or global positioning system units, which require spatial data to be in a compatible format, the most common of which is GPX, which is short for GPS Exchange. Once the new data is collected in the field, this same format is transferred from the GPS units and converted by QGIS into a GIS format. So, click on the Add Vector Layer button and click Browse and locate the folder 01 Training Data, 03 GPS. Ensure GPS Exchange format is selected as the file type, or just select All Files. Select the file surveyboundaryextents.gpx and click Open and Open again. Time for a question. What are the layer name options in the GPX file? Select the layer name Waypoints. It has a geometry type of point and click OK. Then activate the layer in the table of contents and drag it to the top of the layers. So we can see the data more easily, let's deactivate all the layers in your table of contents except for waypoints and mainland. At this point, let's save your workspace. Although there's several modern apps out there that'll allow you to create polygon features, handheld GPS units and the majority of apps will only allow for point data collection. We can, however, use these GPS locations from our imported GPX file as ground truthing locations, which enables us to create site boundaries in QGIS. Before we can get started on this, we need to first create a blank shapefile to store the new boundaries in. So click on New Shapefile and select the type as polygon. Then specify the CRS as GDA94/MGA Zone 50. Under New Field, create the following fields. We want name, site name, and for the type, we want text data. The length will be 50, and click Add to Fields List. Note that field names must be less than 10 characters in length, or they'll be automatically truncated. Use underscores instead of spaces, and remember not to use any special characters, such as the @ symbol, percentage, and so on. Click OK. Save the data as surveyboundary.shp in the folder 02 Training Outputs, 01 Shapefiles. Then click Save. QGIS will automatically add the shapefile to your table of contents. Activate your new layer in the table of contents and rename it to Survey Boundary. Then let's change its style. So for symbol layer type, we'll go with Outline, Simple Line. And we'll give it a red colour and a pen width of 1 mm. And click OK. You won't see the red outline as we haven't actually added any geometry to the new shapefile yet. If you want to check this, just open the attribute table and you'll see that it's actually blank. When you add your first boundary to the map canvas, it'll appear as a red outline like we specified. Before we get started digitizing, we want the ability to align our boundary corners exactly to the points given to us in the GPX file. And to do this, we need to activate snapping for the waypoints layer. So in your menu bar, click on Settings, Snapping Options. The Snapping and Digitizing Options toolbar should appear. Ensure the layer selection is set to Advanced. If you can't see the same information as I've got on my screen here, select All Layers from the Snapping Mode drop-down and then Advanced again. Change the snapping tolerance of the waypoints to the following: For mode, choose to vertex and give it a tolerance of 15 and set the units to pixels. Note the tolerance for snapping can be set to either pixels or map units. Pixels are based on your current screen pixel size, and map units are based on the units specified in your workspace. If you want to know what these are, see Project, Project Properties, General. Setting the tolerance to pixels is useful, as you won't need to change the tolerance if you're zooming in and out of your map canvas. Also note that tolerance amounts for snapping are dependent on your data, and although there's no ideal number, the defaults in QGIS are usually sufficient. However, if you do have issues snapping successfully, you might want to bump the tolerance up a bit. Make sure waypoints is checked and deselect all the layers except for waypoints, because we don't actually want our data to snap to any other datasets. Time for a question. In the options, other than a vertex, what else can you snap to? Also note that although your other layers may be deselected in the table of contents, you're able to still snap to them when you're digitizing. Deselecting them in the snapping toolbar stops this from occurring. We're now ready to create new features with our blank survey boundary layer using the loaded GPS locations. So first ensure the survey boundary layer is selected in the table of contents, then activate the toggle editing tool and click on the Add Feature tool, that's this one here. Hover over one of the leftmost points in the waypoint layer. You should notice a small pink cross appears. This indicates that your cursor is snapped exactly to the location of the waypoint. So click on that waypoint, and then when you move your cursor away, you should now see a faint dashed line. This shows that you've digitized your first vertex in the survey boundary layer. And to stop digitizing, right-click. The attribute table form will appear, so let's fill out the following details. Give it an ID of 1, and the site name is going to be Site A. And click OK. Well done, your first site is complete. It's also common to use aerial or satellite imagery as a backdrop when digitizing features, since the GIS officer can use field notes and visual cues like roads, rivers and vegetation to add more detail to their survey boundaries. So based on the image that I'll pop up on the screen here, repeat the digitizing steps to finish the other sites for your project, and we'll call them Site B, Site C and Site D with the sequential ID numbers. When complete, click Save Layer Edits and deactivate toggle editing. You now have your survey boundaries stored in a shapefile that were digitized from your GPS waypoints. Take a look at your attribute table. So we now have our boundaries, but the attribute data within them isn't complete. For this project, we've been given data standards for the attributes of our spatial data. Often companies will establish standard work practices around field names and entries to ensure quality and consistency across their datasets. This makes the information easier to interpret and analyse in the future. We could add these fields and fill them out via expressions, but this could be time consuming. So alternatively, we're going to add spreadsheet data via a table join. Joins work by linking a value in both the data and the table. These values have to be identical for the link to work. Firstly, we need to convert the spreadsheet into CSV so we can import it into QGIS. Open 01 Training Data, 02 Excel, Survey Boundary Details.xls in Microsoft Excel. And click File and Save As. Choose CSV, delimited or .csv from the Save as Type drop-down and save the CSV table to the folder 02 Training Outputs, 02 Excel. When a message appears, click OK, then Yes, then close Microsoft Excel, and if a message pops up asking you to save the CSV file, just click Don't Save. In your QGIS workspace, click Add Delimited Text File and open the CSV file you just saved. Ensure CSV, separated values is activated, and ensure number of header lines to discard is 0 and first record has field names is activated, and also make sure that trim fields is activated, and then make sure the geometry definition has no geometry attribute only table activated, and click OK. This is going to import your CSV file as a table into your table of contents. Now we need to join this table to our survey boundaries data. So right-click the survey boundary layer, not the CSV table, and click Properties, then Joins, and click the Add button. In the Add Vector Join window, complete the following details. For Join Layer, go Survey Boundary Details, and the join field is going to be Site Name, and the target field is going to be Site Name. This is where it's important that you entered your site name records accurately. We're using this field to tell QGIS to perform the join, so accurate spelling is really critical here. Check Custom Field Name Prefix. Delete the text Survey Boundary Details from the text box, as we don't actually want a prefix in front of the field name for this example, and click OK and OK again. OK, open the attribute table of the survey boundary layer. You should now see the joined attributes. This is only actually a temporary join in the workspace. It's done purposely in QGIS so that you can check to have the desired result before saving anything permanently. To actually save these attributes permanently, you're going to need to export and save the layer as a new shapefile. So close the attribute table, then right-click the survey boundary layer and click Save As. Then complete the following details. For format, go Esri shapefile and save as survey boundary atts.shp in the folder 02 training outputs, 01 shapefiles. And for the CRS, choose Layer CRS. Just double check that it's actually GDA/MGA50. If not, you'll need to change it to selected CRS and browse for the right CRS. Then activate Add Saved File to Map and click OK. This is going to add the new layer to your table of contents. And then rename that layer Survey Boundary Final. Copy the style from the old Survey Boundary layer to the new Survey Boundary Final. You remember we've covered this in a previous exercise. Then activate the Survey Boundary Final so that it's visible in the table of contents. Remove the following layers from your table of contents as they're no longer required: Survey Boundary Details, and Waypoints. Note that you can remove more than one layer at a time by using Control-click. Open the attribute table of the Survey Boundary Final layer. Question time. What would happen if your join field attributes don't actually match? As a hint, you might need to check your data to ensure the spelling within your join field is correct for QGIS to match the features up. Close the attribute table. You may decide to rename the field names after they've already been created. Often the fields created in the join process are cryptic or truncated, or just not quite what you wanted going forward. You can do this using the Refactor Fields tool. Go to the Processing menu and click Toolbox. In the search box, type in Refactor Fields, and it should appear below under Vector Table Tools, so click into it. Then change the input layer to Survey Boundary Final and click Yes to reset the field mapping. The layer's attributes should now appear under Fields Mapping. We want to rename the field Method, so double-click Method under the name column and enter the new field name SUR_method. Just look at the capital letters there as well. Then under Refactored, we have to save the boundaries to a new layer. Click on the three dots and save to file as Survey Boundary atts_refactor.shp in 02 training outputs, 01 shapefiles. Then click Save. Make sure Open Output File after running algorithm is activated. Once new boundaries are loaded into the map view, review the renamed attribute field. Then close the attributes table. Copy the style of Survey Boundary Final and paste it into the refactored boundary. Then remove the old layer Survey Boundary Final and rename the new layer to Survey Boundary Final. Note that you can also use the Refactor Fields tool to reorder your fields or clone, delete, or create other fields. At this point, let's save your workspace again. Checking your spatial data, or quality control, is an important step in GIS data processing and analysis workflows. Often this step is completed by a second person to apply a fresh pair of eyes. Some organisations will even use standard quality control checklists or work instructions to ensure a consistent result. We all make mistakes and overlook things, so this is just a natural part of the process. Add the vector data survey vegetation from the folder 01 training data, 01 shapefiles, survey data. We need to make a copy of this layer to your output folder before we start editing. So right-click on the survey vegetation layer and click Save As, and save the layer as survey vegetation clean.shp to the folder 02 training outputs, 01 shapefiles. And select Add Save File to Map and click OK. Hover your mouse over the survey vegetation clean layer to confirm that it's saved in your 02 training outputs folder. Activate and drag the layer to the top of the table of contents. Now let's change the symbology of this layer so there's no fill and a medium green border. Deactivate the other layers so you can only see the survey vegetation clean layer. And then remove the original survey vegetation layer from the workspace. Zoom in closer into each of the survey boundaries. You might be able to see various overlaps and gaps in the data, although most are too small to see even when you're zooming in close. These issues are usually created when the snapping tool isn't used, and they're usually really small, so they can easily be overlooked. For visual purposes, these tiny gaps and overlaps may not be important, but when they're used in calculating statistics or conducting GIS analyses, clean inputs are really critical. For example, you might need to determine the area of each vegetation species per property, and if your data is not clean, you're going to get incorrect results. The term topologically correct means that the data is clean and structured well, with no overlaps, gaps, line segments not joining where they should, and so on. There are various other tools that can help us identify these topological issues. In the menu bar, click the Topology Checker button, which should be located on the left toolbar. Looks like this. If the button's missing, check that the tool's activated in Plugins, so go to Plugins, Manage and Install Plugins. A sidebar will appear to the right of your map canvas, and click on Configure, and then add the rule Survey Vegetation Clean, must not have gaps, and click Add Rule. Then click OK, and validate all. Your map will now be highlighted red with any gaps. Ensure that your snapping options are on for vertex for the survey vegetation clean layer in the settings menu. And change mode to vertex to 15 pixels. And double click on one of the errors listed in the topology checker table, and that's going to zoom you into the polygon with the gap in the map canvas. Click on Toggle Editing and amend the areas that contain errors using the Node tool. And to start moving these vertices, just click on a red cross so it becomes a square, and then you can start dragging it around. And where there's gaps, move the vertices off its original position and snap back in place. Click Validate All when you've made some changes to see if you've removed the gaps. Repeat this process for all the other gaps. Once complete, click Save Layer Edits, and then repeat the above process, but for the configuration must not overlap. Save the edits once all of your data is clean, then remove the layer Survey Vegetation Clean from the workspace. Save and close your workspace. Congratulations! This brings us to the end of exercise 5. You should now have a solid set of skills and knowledge around creating and modifying spatial data and working with attribute data in QGIS. Thanks for watching.